Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your measurement of pH by a colorimetric method. Okay, so the measurement of the pH by our electrometric method are already discussed and it is uploaded our account. You can go and check the video. But here what we are going to do, we are going to discuss about the measurement of the pH by the method that is your colorimetric method. Now let's start today's lecture. First of all, we are going to discuss about the introduction of today's lecture. pH is what? pH value is a logarithm of reciprocal of the hydrogen ion activity in mole per liter. pH is defined as the logarithm of the reciprocal of the hydrogen ion activity in a mole per liter. In water solution, variation is pH value from 7 are mainly due to the hydrolysis of the salt of strong base and weak acid or a vice versa. We all know that the pH of water are what they are 7. Okay, and if there is any variation of the pH of if there is any variation from pH 7 in water are occurred due to the hydrolysis of the salt of strong base and weak acid or the hydrolysis of the salt of strong acid and weak base. Some dissolved gases like carbon dioxide, hydrogen sulfide and ammonia are also affect the pH value of the water. But the overall pH value of the natural water is in between the 6 to 8, and in case of the alkaline thermal spring water, pH value may be more than 9. Okay, if there is a alkaline thermal spring water, then in that case the pH of the water will be 9, and in for a acidic thermal spring water the pH value will be 4 or less than 4. This industrial wastage also affect the pH of the pH of the water may be strongly acidic or basic, and their effect on a pH value of receiving water are totally depending upon the buffering capacity of the water. pH value of a water are obtained in a laboratory may not be the same as that the time of the collection of the sample. Okay, so that's why it is recommended that collect the sample when we collect the sample as soon as possible, we have to measure the pH. Otherwise its pH value are deviated, and its deviation are occur due to the loss or absorption of the different gases, reaction with the sediments, hydrolysis and oxidation or reduction taking place within the same sample water. pH value should be preferably by determined at the time of the collection of the sample. Now the first one is your principle. So series of indicators and the buffer solution are used for the determining by the pH value by a visual comparison. Okay, so there is a series of the indicators and the different buffer solutions are used for determining the pH value by the visual comparison. The first reagent that is your indicator that is used in this experiment is prepare a universal indicator by dissolving 0.05 gram of methyl orange, 0.15 gram of methyl red, or 0.3 gram of bromomethylone blue, and 0.35 gram of phenolphthalein in 1 liter of alcohol, 66%. Okay, so what we have, suppose that this is a 1 liter of beaker. Now in that what we have to do, first of all we add a 500 ml of alcohol. Now into it, first of all we are going to add a 0.05 gram of methyl orange. Okay, then after that we are going to add 0.15 gram of methyl red. Then we are going to add 0.3 gram of bromomethylene blue. Bromomethylene blue. Then at the end we are going to add 0.35 gram of phenolphthalein. Okay. When all these components are completely absorbed into the 500 liter of alcohol, then again we are going to add the remaining 500 ml of alcohol. And this is how we prepare the reagent, and the color changes are like this. pH. Here the first column is for the pH and the second column is for a color. Okay. If the pH is up to red 3, then the color will be a red. If the pH is 4, then the color will be a orange red. If the pH is 5, then the color will be a orange. If the pH is 6, then the color will be a yellow. If the pH is 7, then the color will be a yellowish green. If the pH is 8, then the color will be a greenish blue. If the pH is 9, the color will be a blue. If the pH is 10, the color will be a violet. If the pH is 11, then the color will be a reddish violet. Now the next is your prepare a indicator solution as follow. After that we have to prepare an indicator solution. The first column is for a name of the indicator, then pH range, then color change, then the method of the preparation. So first indicator that we have to prepare is a thymol blue acid range. Its pH will be at the range of 1.2 to 2.8 and the color will be red to yellow. Okay, so method of the preparation, for this we have to weigh 0.110 gram and 10.7 ml of N50 sodium hydroxide solution and dilute it with the water to a 250 ml. Okay, we have to weigh a thymol brew 0.10 gram and into it we are going to add a 10.75 ml of N by 50 sodium hydroxide solution and diluted with the water 250 ml. Next chemical is your bromophenol blue, whose pH range is at the between 3 to 4.5 and the color range is yellow to blue. Weigh 1.10 gram, add 7.4 ml of N sodium 50 sodium hydroxide solution and dilute it with the water to a 250 ml. Next is your bromo bromocresol green, whose pH range at the between of 3.8 to 5.4 and the color change in color is yellow to blue. And the method of the preparation, weigh 0.10 gram, add 7.15 ml of N by 50 sodium hydroxide solution and dilute it with water to a 250 ml. Next is your methyl red, whose pH ranges 4.2 to 6.3, color red to yellow, weigh 1.0 gram of 1.0 gram and 18.60 ml of N50 sodium hydroxide solution and dilute it with water to a 250 ml. Next is your bromol thymol blue, phenol red, cresol red, thymol blue alkaline range, thymol phylaphthalene, thymo violet. Okay, bromophenol pH range 6.0 to 7.8, phenol red 6.8 to 8.4, cresol 7.2 to 8.8, thymol blue 8 to 9.5, thymol clean 9.3 to 10.5, thymol violet 9.0 to 13.0, yellow to blue, yellow to red, yellow to red, yellow to blue, colorless to blue, yellow to green to violet. Okay, again for all the way we have to weigh 0.10 gram, add 8.0 ml of N sodium hydroxide in case of bromothymol blue. In case of phenol red, weigh 0.10 gram, add 14.20 ml of N sodium hydroxide. In case of cresol red, weigh 0.10 gram, add 13.10 ml of N by 50 sodium hydroxide, and the rest is in a table, you can check it. Now the next is your procedure. Take 100 ml of the sample in a hard glass tube and determine the approximate pH by using a universal indicator. Repeat using a solution of the indicator about 1 by 20 of the volume of the liquid being tested. Then it is corresponding to the approximately pH which are found just above. Now compare the color produced with the series of the buffer solution which are already prepared, and by this way you know the pH of the sample. Now the next is your report. Report the pH of that buffer solution which match with that of the sample to the nearest 0.1. So this is all about the measurement of the pH by the colorimetric. I hope you will understand. If you have any query related to this topic, you can ask me in a comment box, or you can follow the ITLS Academy on different platforms like Instagram, YouTube, LinkedIn, WhatsApp, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or for any detail, you can also ask your query to the helpline number that are already mentioned in your slide. That is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.